Fibonacci search technique. Fibonacci search technique is a non-linear programming search technique used to optimize of a function. It is a line search technique without derivative. So at first we need to know what is the Fibonacci number series. So in the Fibonacci number series, f0 and f1 equal to 1 and f2 equal to f0 plus f1 equal to 1 plus 1 equal to 2 and f3 equal to 2 plus 1 equal to 3 and so on. So fn is equal to f of n minus 1 plus f of n minus 2. Now we see an example and we see it clearly in this example. Suppose a function f x equal to x to the power 4 by 4 by 5 by 3 x cube minus 6x square plus 19x minus 7. This is a function, so we need to minimize this function, and this function range x is between 0 to minus 4, that is given, and L level of level of uncertainty also given, this is 0.433. So we need to optimize this function, minimum value of this function. How can we start? First we need to know how many numbers of iteration is required. So in this case we need to know that fn is greater than equal to b1 minus a1 divided by L, where b1 a1 is minus 4 and b1 is equal to 0. Then we plot this. So b1 4 divided by 0.33 equal to 12. So fn is greater than equal to 12. So here f3 equal to 3, we find that f3 equal to 3 and f4 equal to 3 plus 2 5 and f5 equal to 5 plus 3 8 and f6 equal to 8 plus 5 equal to 13. So 13 is greater than equal to 12. So n equal to 6. So the number of iteration is n equal to 6. Now we plot a table and see it the calculation. Say first is iteration, and this is so at also we know the in the k is the number of iteration, we assume that, and it is bk, and this is lambda k, and this is mu k, and this is theta lambda k, and theta mu k. This is the table we need to plot. So then we also see the line search. This is a k and this is bk. K is the number of iteration, k equal to 1 2 3 and dot. So we first need to establish 2 points between ak and bk. Now we and see that this 2 point is lambda k and mu k. Okay, so how we can find the value of mu k? Mu k is equal to ak plus f of n minus 1 by f of n into bk minus ak. This is the formula. And lambda k is equal to ak plus f of n minus 2 by fn into bk minus ak. Or also we can find the lambda k value by plotting ak plus bk minus mu k. This is a also possible value. So here we can find that value of the mu k, lambda k, and in its value. So iteration number k, first iteration, so 1 ak, here ak is -4, write it, and bk, b1 is 1, for number of iteration is 1, then this is 0 0, and lambda 1 here. So lambda 1 we can calculate this value mu k. So mu k equal to ak plus f of this, the formula. So we put this value ak equal to a1, for a1 is given that -4 and b1 equal to 0. So we put this value -4 plus f of n minus 1, f of n minus 1, the number total n equal to 6, so n minus 1 is 8. So f of n minus 1 8 by 13 into bk minus ak. What is the bk? And bk is 0 plus 4. So 8 by 13 into 4 ak minus 4. So here this value is minus 1.54. Okay, and this is minus 2. So how we can find this lambda k? Lambda k value is we can find this by using this formula ak plus bk minus mu k. Okay, so here ak is -4 and bk is 0 and my mu k is minus 1.54. So this plus, and so it is minus 2.46. Okay, this is the value. So this we can write it to minus 2.646. And theta lambda k value, how we can find this theta lambda k? So theta lambda k is equal to theta minus 2.46. This is the functional value of this. So here this minus 2.46, we put this value in the function, in this function. Okay, and we find that minus 2.46 to the power 4 divided by 4 minus 5 by 3 into minus 2.46 cube minus 6 into minus 2.46 square plus 19 into minus 2.46 minus 7. Okay, so here the value is minus 74.39. You can calculate it. So this is a minus 74.39 and this is the value of minus 49.33. Okay, so here theta mu k we can also put the value of mu k minus 1.54 is in the equation of f minimum in this equation, and we can find the value of minus 49.33 theta mu k value. Okay, so here we see that theta mu k and theta lambda k, two value, and we compare that theta mu k is greater than theta lambda k. Okay, so for minimization problem, we can, so this is a minimization problem, so we can eliminate the mu k to b k, this part, and the new point is ak, new point ak comma mu k. Okay, for minimization. And for maximization, so now we can write forward the next iteration. So iteration number 2. Here ak is minus 4 and bk is mu k. Okay, this is minus 1.54, and we see that mu k value is minus 2.46 and lambda k value is minus 3.078. We can calculate this value in the similar way in the formula and in this formula and in this formula, and we can find the value of lambda k and mu k and put this value in the function of x. Then we find the value of theta lambda k is minus 59.79 and this is minus 74.45 and so on. So here number of iteration 3, 4, 5 and 6. Sixth number of iteration we can provide it. So I calculate all the value in the calculator, so you can calculate this, and the functional value is minus 56.09 within the range, so minimization of the functional value is minus 56.09 within the range of minus 2.77 to minus 2.46. This is the answer. So our answer is minimum f minimum is minus 56.09 within the range of a to b is minus 2.77 to 2.46. Okay, thank you.